Hello everyone. So my topic is friction estimation of friction factor for flow normal to cylinders. So the question is as this: a vertical cylindrical column with diameter 0.3 meter and height 8 meter is exposed to wind at 20 meter per second. The air properties are given as density as 1.2 kg per meter cube and the viscosity as 1.8 into 10 power minus 5 Pascal seconds. We are asked to calculate the Reynolds number, friction factor, and the drag force. It is a diagrammatic representation of the problem. The velocity is given to us as 20 meter per second, diameter is 0.3 meter, and the height is 8 meters. So the solution is as this. Reynolds number can be found out by rho Vd by mu. So using this, we find the Reynolds number to be 4 into 10 power 5. Now, by using the chart for cylinder, we can find the friction factor CD, which is coming out to be 1.2. And the projected area is diameter into height. This diameter into height. It comes out to be 2.4 meters square. So the drag force can be found out as F equals to 1 by 2 rho V square CD into A. This is further calculated as 691.2 newtons. The second question also goes with the same formula that we have used earlier. It asks us to find out the drag force. A distillation column has an outside diameter of 30 centimeter and a height of 10 meter. Calculate the drag force exerted by air on the column if the wind speed is 25 meter per second. So the area can be calculated as the diameter into height, which is 0.3 into 10 as 3 meter square, and the drag force can be calculated as 1 by 2 rho v square into velocity. 1 by 2 rho v square into this CD value. This is the CD value into area. So the drag force comes out to be 1350 Newton. That is what it was asked in the problem. So the third question is that two cylinders are placed in the same airflow, same velocity, and the fluids are also same. The diameter of the cylinders are given as 0.05 for the cylinder A and 0.1 for cylinder B. We have to find the ratio of the drag forces acting on them, assuming that the friction factor are same. So the solution is like this, that we know that the drag force is proportional to area, which is proportional to the diameter if the height is same for both the cylinders. Now considering the height is same for both the cylinder, we can have the ratios of the drag forces as the ratios of the diameters of the two cylinders. So FA by FB would be dA by dB, which is 0.05 by 0.1, which is 0.5. The ratio is thus 0.5, 1 is to 2. The fourth question is: wind blows across a cylindrical pole of diameter 0.2 meter and the height as 5 meters at 25 meter per second. Find the power required to resist the drag force. The hint is given that power is force into velocity. So we will first find the projected area. Now wind is flowing in this direction, so the projected area would be diameter into height, which is 0.2 into 5, 1 meter square. And the drag force is half rho v square into area into CD. CD is calculated earlier as 1.2, so the drag force can be calculated as 450 newtons. And the power required is drag force into velocity. So the drag force was 450 into velocity is 25 meter per second. So 450 into 25 meter per second, which is 11.25 kilowatts. That's it.